Well, it's 3 p.m. my time, so at the top of the hour, and I think it's a good time to start. So start off by welcoming everybody that's signed in to the workshop already. My name is Mark Parrington. I'm a scientist at European Centre for Medium Range Weather Forecasts based in Bonn in Germany. We're starting with this slide to show there is a Slido where we're canvassing you for where you are joining from today. And I think the link might be in the chat, or else you can go to Slido and use the number there on the screen to fill that in. I'm going to kick things off with some background and motivation for this workshop. There'll also be an introduction from Tim Butler from HTAP, who are co-hosting this workshop with us, and then Rebecca Buchholz will go through some of the protocols and the administrative aspects of the workshop for the next couple of days. So I'm going to take control of the screen, share my screen with these Slido surveys will be shown in the breaks and at various points to show the results, and so everyone can see who's coming from where and their interests in this workshop. So I'm going to share my screen. Here. And full screen. Okay, so could somebody please confirm that you can see the slides in presentation mode?
Yep. Yes.
Yeah. Okay, great. Thanks. Okay, so yeah, welcome. This is a very exciting couple of days that we've got ahead. The BBURNED activity is part of IGAC, and I'll explain very briefly in the next couple of slides what that is. But this is the first such workshop along these lines under an IGAC activity that's been organized since 2017, I think, and many people who are involved and presenting at this workshop were in that workshop too. And so it's very timely. A lot's changed in that intervening period, and so it's very timely to have this workshop now and to look at the landscape and the state of the art for fire emission estimation. So we have 4 hours today, tomorrow and Thursday, and then this writing up session on next Tuesday. And we have 4 hours per day starting at 1400 UTC. And the basic timetable is shown on this table, but the full agenda is in the website, and the link will be shared in the chat throughout the meeting. So just a couple of slides to give very brief background. There's a lot of text in these slides. I'll just give the very basic information. So we are an activity under, BBURNED is an activity under IGAC, which is the International Global Atmospheric Chemistry. And this is basically a coordinating organization for the atmospheric chemistry community across different scales, across different disciplines, and under these focal activities that are listed here. And the diagram gives a schematic of how these things are all linked together to some degree. IGAC itself is under the umbrella of Future Earth and is jointly sponsored by the International Commission on Atmospheric Chemistry and Global Pollution, and has a community of about 1,500 scientists, including students, policymakers, stakeholders, general public, across all continents. And the things that IGAC does are divided up amongst a handful of activities that cover all aspects of atmospheric chemistry, from lab-based kinetics all the way up through emissions, atmospheric chemistry processes in different environments, and also there was a need for this fire emissions activity too, which I'll come back to shortly. And funding for IGAC comes from NASA, NOAA, NSF, and NIES. And so as I mentioned, there's a number of activities that come under IGAC. And there was in the past a biomass burning activity, which unfortunately became a bit inactive a few years ago. And so given that there's a growing interest in wildfire emissions and how important they are for atmospheric chemistry research, there was a clear need for IGAC to have a focused activity on this. And the idea is to coordinate activities, particularly around understanding the uncertainties in biomass burning emissions, and linking this to other IGAC activities, and then the wider atmospheric chemistry and atmospheric science community. But it's community-led, community-driven, and the feedbacks are there to really be across the whole community. We'll come to these issues several times over the next few days, I'm sure, but basically the main sources of uncertainty for biomass burning and related smoke chemistry are listed here. So obviously knowing where the fires are, how we convert the amount of burning vegetation into emission, and this depends on the vegetation types, the combustion stage, the state of the combustion. The point here is to show it's very complex. There's a lot of processes, they all interact in different ways, they all have different uncertainties, and those interactions themselves are uncertain. So we're really trying to focus then on identifying and quantifying those uncertainties. This is on the scientific side, and I'm sure that all the presentations will cover these to different degrees. But as well as the scientific applications, in the last few years, I've been working on science communication around wildfire emissions and atmospheric chemistry and pollution for about 7 or 8 years now. And in that time, there's been a very clear increase in the amount of coverage that wildfires around the world get. So what I'm showing here is there was the UNEP report on wildfire that was published at the end of 2021. The main message from this was an anticipated 50% increase in wildfires by the end of the century, but also an elevated risk of wildfires in the region, which had little prior history of wildfires in the past. So, for example, within the Arctic Circle, as we saw very clearly in 2019, 2020. So essentially, away from the tropics, away from the seasonal fires, and in those more remote areas where wildfire is changing with climate change. And at the same time, there's this increased media activity. So the screen capture here shows a number of headlines from global media related to Canadian wildfires earlier this year. This is from an article by Carbon Brief, and they've written other articles that look at the media reaction to wildfires in different parts of the world. But as we know, and as we'll see throughout the next couple of days, there's a lot of variability between the different biomass burning data sets, and this depends on species and the biome, and there's a lot of different factors. And this is a figure from Christine Wiedenmeyer's paper earlier this year. I'm sure Christine will talk about this in her presentation later today. So understanding and improving the quantification of these uncertainties, this is really important, because as scientists, we have an opportunity here to really engage with global media, providing data-driven and reliable information on wildfires and the atmospheric impacts, but also for tackling misinformation, because unfortunately there is a lot of that in the media and in social media too. And the links to these are given at the bottom of the slide. So it's fairly obvious, hopefully, from what I've seen, but the overarching goal of BBURNED is to quantify uncertainty and variability in biomass burning emissions and the resulting atmospheric chemistry, to coordinate these activities around the international scientific community. There are other activities on wildfire, which are all doing fairly similar things, but we're communicating with those and trying to optimize the information and the way that we communicate around this. And our activity started officially last December. This has been a lot of work behind the scenes by myself and my scientific steering committee fellow scientific steering committee members. And the first major deliverable from our activity is this workshop. So hopefully this is going to be very helpful for defining what we do in the future in BBURNED. So I mentioned, you can see in they have their videos on the other members of the steering committee. So Rebecca Buchholz, Nancy French, and Cindy Whaley. We had a lot of help from Louisa Emmons from NCAR in getting the activity up and running. And then we have a number of working groups, the leads of which are listed there. And I'll just very quickly outline the working groups. So of the three, there is one on emission estimation led by Medina and Evelyn. There is one on atmospheric chemistry processes led by Stephanie. Both of these working groups, we are looking for volunteers to help to share in the leadership and to define the working groups and their activities. And then the third group is on modeling atmospheric composition. which is led by Gaurav Govardhan and Shaino Susan John. And as well as those leadership roles, volunteers for the working groups and participating in the working groups are highly sought after. And if anybody in the workshop or knows anybody else who would be interested or could contribute or join these working groups, then please do contact us and let us know. And especially early career researchers, we're really keen to get early career researchers into our management and organization, because this is a very exciting topic that's a new science in a way, which is very rapidly growing, and this is a chance to really be in there at the forefront of how things are changing. So this is a very quick overview of BBURNED. I'm now going to hand over to Tim Butler, if he's online, to give the introduction from HTAP. And I'll keep the slides open. So Tim, just let me know when you want to advance the slides.
Thanks a lot for that, Mark. And yeah, thank you for to the whole BBURNED team for the opportunity to come and talk about the HTAP work on wildfires here as well. Let's start with a few words about HTAP itself. The TF-HTAP is the Task Force on Hemispheric Transport of Air Pollution. It's one of many task forces under the UNECE's Convention on Long-Range Transboundary Air Pollution. And the mission of our particular task force is to, as it says here, foster international scientific cooperation to improve the understanding of intercontinental transport of air pollution across the Northern Hemisphere. So that geographic scope comes very much from the UNECE element of what we're doing, but we do have very much a global focus. And so we're also interested in other world regions, basically the whole globe. The kinds of questions we try to answer are there. So how do changes in emissions in one part of the world affect air quality in other parts of the world? And for any given region in the world, how do extra-regional emissions outside of that region affect human health and ecosystem health within that region? And so on these questions, we regularly report findings and scientific results to the convention. Our focus is on several different kinds of pollutants. So we group them into traditional air pollutants such as ozone, PM, and their precursors. These pollutants are covered under the convention's Gothenburg Protocol. We also have a mandate to look at mercury and other heavy metals, as well as persistent organic pollutants. And so we work by doing several different things. So we keep on top of the available literature and report findings and new results to the convention through that. Where possible, we seek to cooperate with other bodies such as AMAP, BBURNED here, of course, TOR, the Minamata Convention, and other groups with overlapping interests to us. And where we see gaps that need filling scientifically, we organize our own multi-model assessments to answer these questions that we're mandated to ask here. So it's important to note we have no funding to do any of this work. We rely on voluntary contributions from the community. And so this means we have to try and align the sorts of policy relevant messages that we need to take to the convention with the scientific interest to encourage people to contribute to this work. Next slide, please. So just a quick example of how we've worked previously in HTAP assessments. It's very much a modeling activity. Of course, we do work with measurements as well, but we're known for coordinating model experiments where we recruit large ensembles of global chemical transport models and use them to run perturbation simulations to derive source-receptor relationships. So you can see that on the picture there. So by systematically reducing emissions in each world region, we can understand how those reductions affect air quality everywhere else. So we use historical emissions and a standard reference period for these runs, and then build an ensemble emulator, so an emulator of the whole ensemble from the source receptor matrix that we get from all of these runs. And then those runs, of course, are interesting in their own right, but we also use them to develop an emulator and use that emulator for rapid scenario assessment. And so doing work like this, we've contributed to 2 reviews of the Gothenburg Protocol, the protocol of the UNECE Convention on Long-Range Transboundary Air Pollution, which covers the traditional air pollutants, ozone and PM, and so on. Next slide, please. So where we're at now in HTAP, the current work plan looking forward for the next 2 years and beyond consists of 5 key points here. with the modeling exercises in the middle there. But on the top, I'll just mention global emissions mosaics. This is an important part of the work that HTAP has done and continues to do. We have a new global anthropogenic emission mosaic out, HTAP 3, we've called that, covering a time series from 2000 to 2018. We're going to continue to explore extension and expansion of that emission mosaic. Of course, we're also very interested in fire emissions there too. And skipping down to the bottom, the decision support tools, the ensemble emulators that I mentioned, will continue to develop this approach to enable use of model results in rapid decision support tools. But the real meat of the work we're doing there is the three components you can see in the middle. So there's work on ozone PM and the deposition of sulfur and nitrogen under future scenarios, which were called opens. This work is designed to support the convention in a potential upcoming revision of the Gothenburg Protocol, which we expect to be happening over the next few years. On our mercury, cooperating closely with the Minamata Convention to look at mercury trends and source attribution. And of course, there's also a lot of work on fires. There's a lot of interest in fires from the convention. And so we've set up a new work plan item specifically looking at fires. So this has a lot of overlap with the opens work on ozone PM and the deposition of sulfur and nitrogen in particular. But it also has a much broader scope because we're interested in a multi-pollutant, multi-impact approach to fires. So including heavy metals, POPs, and so on, in addition to the standard traditional air pollutants, PM and ozone. So that's why we're very interested in the results of this workshop here today, because this is going to be very important for getting good quality emissions to emission inventories to do this work with. And so with that, I'll say thank you and hand back to Mark, Rebecca, who's next.
Okay, thanks, Tim. Thanks for the introduction. And now Rebecca will go through some of the practicalities for the workshop, and then we can start properly. So Rebecca, please.
Great. Hi, I'm Rebecca Buckholtz, and welcome to the meeting. I'll go over some practicalities for how the meeting's going to run and what's going to happen over the next few days. So a reminder that the speakers will be sharing their own screen, but we have your slides in case there are any technical difficulties. Please, attendants, save your verbal questions to the end of the presentations and raise your Zoom hand if you want to ask a question. The Zoom hand is under reactions. There's also, you can add questions to the chat throughout the meeting. And for the presenters, with 2 minutes remaining, the moderator will add a chat message to remind you there's 2 minutes remaining of your time, and then they'll interrupt at the end of your speaking time. Please only unmute yourself when you are participating in questions or the discussion, and a reminder that the Zoom meeting is also being recorded. Next slide, please. So because we are being hosted by UCAR NCAR, we decided to add the meeting code of conduct that we have from NCAR. I'm in the atmospheric chemistry observations and modelling laboratory here, and so I used our meeting code of conduct. Just a reminder to be respectful in our words, tone, and body language. We really want to understand each other today, make space for all voices, be constructive in our comments, and value all individual contributions. Next slide, please. So on the third day, we have time set aside for discussion. And these are some questions that we came up with beforehand to think about as we're going through the next couple of days. There might be some more questions that come up that we want to discuss on that third day, but these are the questions that we encourage you to keep in mind as you're listening to the presentations. So do we understand why different fire emission data sets are different from each other, why they give different results, or do we need more information? What would be the best option for this HTAP multi-model, multi-species fire study that's being planned? Could we create a mosaic of different, using different emission inventories? And is there a consensus on this movement away from MODIS and potentially into VIIRS for the future emission data sets? So please remember to keep these questions in mind, or if you have any other questions that come up, let us know and we can discuss those on the third day. And final slide. This is where we are right now, and we're right on time. So I'm going to hand over to Nancy to get started on the presentations.
Thanks, Rebecca, and thanks for the opening comments. I think we are all set. Perfect timing. We have presentations now, 2, and then we'll have a short break.